You can do it without a cable, but okay. So last time we started talking about structures, and I gave you a structure that looked like this. It makes an equilateral triangle. There's a pin joint up at the top. Every member is 1 meter long. And these are 1 meter apart, so that means all the angles are 60 degrees. And we first isolated the whole thing. And the free body diagram looked like this. The two connections to the ground are pin joints. So I can't remember what did I call those RA and RC? Oh, okay. Okay, so the bodies are numbered 1 and 2, and then the joints are A, B, and C. And so I called this one the force on body 1 by pin A. And then up here, this was 500 newtons, right, this force?
Yeah.
Okay, so this is 500 newtons. We're neglecting all the weights. And then there's the force on member 2 by pin C. And we went through the equations, and one of the things, if you look at the notes are corrected now, but I made a mistake in my calculation, so the video doesn't quite match the notes, just with one of my cosine and sine things. So the equation should look like this. For isolating the whole body, we should have F1AX plus F2CX is equal to negative 500. And then we should have, for the second one, F1AY plus F2CY is equal to 0. And then for the third equation, we should have F2CY is equal to positive 433. Okay, so those are our first three equations. And the variables that we have so far, there are 4 of them. Those are F1AX, F1AY, F2CX, and F2CY. So now we have to go on to the next one, and I think I drew the free body diagram of member 1, but we didn't do it yet. So now, free body diagram of member 1. So remember, member 1 does not include that pin the way we're doing it here, okay? So, and remember that the members don't touch each other, they just touch the pin, okay? So there's not going to be any force like on 1 by 2 or on 1 by the ground. There's only going to be the force on 1 by the pin up here and on 1 by the pin down here, okay? So we have the force on member 1 by pin B. What about the 500 Newton force? No, that's acting on the pin. So that's not there. And then the force on 1 by A. And that's it. So set up the table. All right, so the origin is still, I'm just going to keep the same origin for all of these, although you don't have to. You could move the origin around. What you can't do between like when you isolate the different things in a single problem, is you can't rotate the coordinate system because that'll change the meaning of those forces. But as long as you keep the same orientation of the coordinate system from member to member, you can move the origin. What? Yes, you can change the about point. Yep. Think of it sort of this way, like a system of equations, you're just trying to come up with a bunch of equations that are true, you know? That's all you're trying to do. You're trying to come up with 56 equations that are true, you know? Not in this problem, but in a bigger problem, a worse problem. So it's totally, so when you isolate a body, like, and you use Newton's laws, you're getting equations that are true no matter what about point you choose here. So sure, those are fine, you know. The only problem is if you rotate the coordinate system, then your x and y components end up meaning different things. Those variables aren't the same, and so you get the wrong answer if you do that. That's the only thing that can go wrong on these. So the origin is still going to be under here. The about point, I guess I'll still have at the pin A. So the force F1A, that is at coordinates negative 0.50. The about point is at negative 0.50. So there's no row vector. The force is F1AX, F1AY. Cross product gives you 0. And then at the pin B, this is the one that I did wrong before. This coordinate should be, the coordinates should be 0, positive 0.866, right? That's just a sine of 60 degrees. The about point is this. And so you get positive 0.5, positive 0.866. The force vector is F1BX, F1BY. And so you get 0.5 F1BY minus 0.866 F1BX. Oops. And that's it. So now now we'll go to Newton's laws. So Newton's second law says F1AX, F1AY plus F1BX, F1BY is equal to zeros. And so we get two equations from here. well, I guess I'll put that off. Go to the rotational equation, and you get negative 0.866 f1bx plus 0.5 f1by equals 0. And so we have equations 4 says f1ax plus f1bx is equal to 0. Equation 5 says f1ay plus f1by is equal to 0. And equation 6 says negative 0.866 f1bx plus 0.5 f1by is equal to 0. So yeah, so now let's figure out. So now we have 6 equations. We had 4 variables before. Maybe we can solve this. So we have all of the variables that we had before. We have f1a, x and y. We have f2c, x and y. And now we added all we added was f1b, right? So we have enough that we can solve something at this point, but we can't solve the whole problem yet because we don't know